So in this warm-up here, we have two planes. Notice that these planes are parallel, A and B, so one is on top of the other, or not on top, but above the other. And then there's a line shooting through plane A, through plane B, and out the bottom, okay? So when that line goes from solid to dotted, that means that it's piercing through the plane, it's intersecting the plane. All right, so number one, points D, F, and C are collinear. False, absolutely false. No question about that. I could not put a straight line through those 3 points. They're not in a row. They're not lined up in a row. All right. Points D, G, and S are coplanar. Number 2. Okay, guys, I cannot say this enough. Any 3 points are coplanar. Any 3 points are coplanar. Any 3 points are coplanar. I don't even need a picture for number 2. Erase the picture and number 2 is still true because any 3 points in the universe can be in the same plane. Now, they don't always define a plane because they have to be non-collinear to define a plane, but any 3 points are coplanar. End of story. Number 3. Line FE intersects plane A at point E. Now, point E is where the line goes from solid to dotted or dashed. So we know, it is true because that's where the line intersects the plane. It goes from solid to dashed. Plane B contains points G and S, but not point E. What do you think about that? Number 4. G is in plane B, check. S is in plane B, check. E is in plane A. So that's true, yeah. This is not a difficult warm-up. FE and SG are skew lines. Number 5. FE and SG are skew lines. Good. It is false. Now, why is it false? Because if they're not skew, they could either be parallel or intersecting. Which one are they? Parallel or intersecting? Good. It's false because they intersect at point S. They intersect at point S, therefore they are not skew. Okay. Here are your homework answers. Check those homework answers and make note of the ones you want me to work. All right, here we go. We're going over a lot of homework problems. Let's get started. Number 1, how many lines contain point B? We did this on the second day of school. I told you to draw a point, and then I said, how many lines can you draw through that point? And you guys said an infinite number of lines. So how many lines contain point B? This one, this one, this one, this one, this one, this one. An infinite number of lines. Number 7, how many planes contain line FB? Now, remember, when we were talking about planes, and we only had 2 points on our plane, see this line in this plane? When we only had 2 points, which a line is defined by 2 points, when we only had 2 points, we had an infinite number of planes because this plane can pivot. You see me pivoting this plane? So here's 1, 2, 3, 4, 5. I could keep rotating it around that line. I could still contain this line, and I could make an infinite number of planes. So that's why that one is infinite as well. Because a line has 2 points. And 2 points does not define a plane. It's not enough points to define one plane. Infinite planes. All right, number 11. KM represents the length of a segment. True. Remember we talked about this versus this. This right here is an object. That is a segment. It's not a number. It's not the length of the segment. It's an object. It's a segment. This is a number, like 11 inches. That is the length. It's the distance or length of the segment, the distance between the points or the length of the segment. So that's why that one's true. Number 12. Someone asked, I think, if it could be maybe. There's no maybe here in true or false. We're going to talk about this today, but if you can think of even one time where a sentence is false, then the truth value of that sentence is false. So I can think of one time that this is false, skew lines, and that's why I'm going to circle false. So you were probably saying, well, sometimes it's true and sometimes it's false. But I'm asking if this sentence is true or false, and it only takes one time for it to be false to make the whole sentence false. Okay, number 20. Collinear points are blank coplanar. Here's the deal, guys. It's easier to be coplanar than it is to be collinear. So if they're collinear, if they're in the same line, which is harder to do, then they're definitely in the same plane. Could I put a plane through any 2 points? Absolutely. That's easy to do. So that's why that is always, it's harder to be collinear. So if they're already collinear, then they're definitely coplanar. It's kind of like if you have your master's degree, then you have your bachelor's. Well, it's harder to have your master's, so you definitely, it's a prerequisite. So you definitely have your bachelor's degree if you have your master's. Being collinear is like a prerequisite to being coplanar. Last one, 27. Think of each segment in the diagram as part of a line. 27. DC and EH are parallel. They're both going left-right. They're going in the same direction. They're coplanar, because look at this. I could take a plane. And I could grab both of those lines. They're not skew. They are coplanar. Okay, the last one, I skipped it, was 15. 3 points blank determine a plane. This word is the most important word in that sentence. Now, I told you that 3 points are always coplanar. I said any 3 points are coplanar, and I'm sticking by that statement. But being coplanar is different than determining a plane. If I take a tripod and I put all of its legs in a row, in a line, will that tripod stay standing if someone comes and touches it? No, it's going to fall over. So 3 points determine a plane, but only if they're not lined up in a row. So they have to be non-collinear. And that's why it's sometimes, because these 3 points determine a plane, and these 3 points do not determine a plane. Now, are they coplanar? Yeah, those are coplanar, but they don't determine a plane. See the difference? Okay. Plot C, -2, 4, and D, 1, 4. C and D. Use a straight edge to draw, be careful, it's hard to see on your screen. It says to draw ray CD. And if you're just watching, that is okay. All right. Rotate your ray 180 degrees. I want you to picture that ray rotating 180 degrees. Picture it. What would it look like? Just picture it. Did you like my sound effect? Is the result still a ray? Yeah. It's going in an opposite direction. Very good. Make a conjecture. So if I rotate a ray, whether I rotate it clockwise or counterclockwise, 180 degrees, then I'm going to get a ray that's going in the opposite direction. What else happened with the pink ray and the green ray? What do they form? Yes, they do, Neil. Yes, they have the same endpoint. It forms a line. So that's a conjecture. If I rotate a ray 180 degrees, the result is a complete line because one is going to the left and one is going to the right, and so they go on forever. Okay, so this is one of the words on your vocab sheet. You've already written this word. You've already written it, so you don't need to add anything to your vocab sheet. This was already on there. Opposite rays, there's a lot of words here. First of all, it's only 2. There's not 5 of them. Opposite rays are 2 rays that are collinear. What does that mean? They're in the same line, and they have to have the same endpoint. So these are important words. They have to be collinear, and they have to have the same endpoint. Opposite rays. Okay. So, I'm waiting for it to show up. Name 2 pairs of opposite rays. Let me just call on someone. Okay. He said AF and BC. Ray AF and ray BC. Are those opposite rays? No. Let's try again. Okay, so AB, and BD. Uh-oh. Wrong again. Those are not opposite rays. Let's try someone else. Here's a good example. Ray BA and ray BD are opposite rays. Ray BA and ray BD are opposite rays. Do they have the same endpoint? Check. Are they going in opposite directions? Check. Are they collinear? Check. Phew, that was scary. Can you name another example? Because it said 2 pairs. I'm kind of scared to ask. Name another pair. No. No. I'm just going to write the other pair. Some of you are probably writing it. Y'all are typing too fast for me to catch up. DF and DB. That's an example. DF and DB. That's another pair of opposite rays. They have the same endpoint and they're collinear. BA and BF would work. Yeah. Okay. What is the relationship? New question. Let's erase all that. What's the relationship? Sorry, I'm doing some erasing. What's the relationship between ray BD and ray BF? What's the relationship between ray BD and ray BF? They are the same ray. BD and BF are not 2 separate rays. They are the same ray. Because one starts at B, goes through D, and goes on forever, and one starts at B, goes through F, and goes on forever. BD and BF are the exact same ray. They're not different rays. So that's 2 different ways to name the same ray. Okay, now we're going to get into today's lesson. That was kind of leftover vocabulary that we hadn't hit yet. Now we're in today's lesson. We're in the notes that say logic and reasoning notes. This is today's lesson. The first word, you're going to have to write pretty small because Miss Tanton did not give you a lot of space to write the word. My bad. Okay, the first word is conditional. Has this been kind of weird for you guys? You're like, I'm in math class, but I haven't dealt with any numbers yet. Is this weird? Today you won't deal with any numbers either. This is different. Don't worry, Monday the numbers will start. We are going to deal with numbers on Monday a lot. But today it's going to feel like you're in English class. Okay, here we go. A conditional is a statement that can be written in the form if P, then Q, where P is the hypothesis and Q is the conclusion. Let me give you some simple ones before we read that one in blue. Don't write anything under the example yet. If it is cloudy, then it will rain. If you do your homework, then you'll pass the quiz. Those are if-then statements. If you give a mouse a cookie, then, I read this book to my daughter almost every night, he'll ask for a glass of milk, or whatever. Okay? So, that's a conditional statement. Statement in the form if, then. On your notes where it says notation, I want you to write if P, then Q. Or you could write the word then if you don't want to do the arrow, but the arrow does mean then. If P, then Q. That's what you write in the notation. So here's a geometry example. If two rays with the same endpoint form a line, then they are opposite rays. If, then statement. Okay? Now, a conditional has two parts. It has the hypothesis and it has the conclusion. The hypothesis is the P and the conclusion is the Q. So, number 2 on your sheet is hypothesis, and number 3 on your sheet is conclusion. The hypothesis comes after the word if. So if I said, if it is cloudy, then it will rain. My hypothesis is, it is cloudy. You don't include the word if, it's what comes after the word if. The conclusion would be, it will rain. Not the word then, but what comes after the then. So it's like the first part is the hypothesis and the second part is the conclusion. Yes, Nathan, you're getting ahead of us. So the notation for hypothesis, just put the letter P, and for the conclusion, just put the letter Q on your notes. If two rays with the same endpoint form a line, then they are opposite rays. So the hypothesis is that the two rays are forming a line, and the conclusion is they are opposite rays. Hopefully we're okay here. Alrighty. Y'all were getting ahead of me. The next word on your sheet is converse. This is word number 4, converse. Neil asked if we have to use P and Q for the notation. These are your notes, so you can write whatever you want. But in the future, I will be using P's and Q's because it's going to start to get more complicated later in the 6 weeks. And that's all I'm going to say about that. Okay. Converse. This is when you reverse the statement. Converse, reverse. Converse, reverse. The converse is the statement formed by exchanging the hypothesis and the conclusion. If it is cloudy, then it will rain. If it rains, then it is cloudy. If you do your homework, then you will get an A. If you get an A, then you did your homework. You are just trading places with the hypothesis and the conclusion. Or the shoe company Converse, short. So, if two lines are parallel, then they never intersect. The converse is, if two lines never intersect, then they are parallel. They share the same meaning. No. Sometimes the conditional is true and the converse is false. Kind of like, no, it's not the same meaning. Good question. So in this example, the conditional is true. This is a true statement. And the converse is false. The converse is a false statement. So they're not always the same statement, the same reasoning. Okay? And we're going to go on to that in a minute. Okay. Counterexample. This is number 6. This is the last word for today. We're not going to fill out your whole notes today. Counterexample. An example that shows a conjecture to be false. This is when we get to prove things wrong. Counterexample. Oh, I'm sorry. It's 5, not 6. My fault. It's 5. Counterexample. Prove the statement wrong. Turn the statement into a liar. Draw a figure that would prove this conditional false. If two rays with the same endpoint travel in different directions, then they are opposite rays. So try to prove that statement wrong. Okay, I'll draw two rays with the same endpoint. They are traveling in different directions, but they're not opposite rays. So I just proved that sentence false, and this picture, the picture is my counterexample. So sometimes a counterexample is a word, and sometimes a counterexample is a picture. Sometimes it's a word, sometimes it's a picture. Counterexample means prove it false. Now, a counterexample is going to make the hypothesis true and the conclusion false. So, if two lines do not intersect, then they are parallel. I want the beginning to be true. I want them to not intersect. But I want the end to be false. Can you think of lines that don't intersect, that are not parallel? Boom, skew lines. So I just proved that sentence false by keeping the hypothesis true and turning the conclusion into a liar. Are there any other types besides pictures and words? Not in our class, there's not. In our class, the counterexample will either be a picture or a word. In this example, the counterexample is a word. The word is skew. Word. Yeah. Okay. Let's see if we can put all of this together. Just watch, or you may write this in your notes if you would like to write this in your notes. Can I draw a picture of skew lines? As your counterexample, yes, you could, but I would rather you write the word skew lines. Thank you for asking. All right. If today is not a weekday, then it is Saturday. By the way, this is the hypothesis, and this is the conclusion. True or false? I don't want you to say, well, sometimes. I'm not asking always, sometimes, never. I'm asking true or false. And you said false. Because if you can think of even one time that it's false, then it's false. Counterexample. Sunday. Good. Sunday makes this part true and this part false. Would Monday be a counterexample? No, because Monday doesn't make the hypothesis true. All right? What's the converse? This is when we reverse, switch places. If it is Saturday, then it is not a weekday. That is messy. I'm sorry. Okay, validity means true or false. Is that true or false? If it's Saturday, it's not a weekday. That is true all the time. I can't prove that statement wrong. I can't prove that statement wrong. If today's Saturday, it is not a weekday today. It's the weekend. Counterexample? There is no counterexample when the statement is true. The counterexample doesn't exist. Are we okay with this? So the conditional was false, and the converse of the conditional was true. Converse and conditional are different. Yep, a conditional is just an if-then statement. Does the order of a statement matter? Yes, it does. This part's fun. This is my favorite part of the lesson. So, with my students in class, I have them stand up. For you guys online, I want you to raise your hand. You know how to raise your hand online with that little guy raising his hand? Raise your hand if you are a counterexample to this statement. Ready? Don't raise your hand yet, Neil. If you are a Texan, then you were born in Houston. Raise your hand if you're a counterexample. Where were y'all born? Where are you born? Good, good on us. Mexico, then you're not a counterexample. New Jersey, you're not a counterexample. Vietnam, you're not a counterexample. Kenya, you're not a counterexample. India, no. None of these are counterexamples. Dallas, that is a counterexample. I was born in Dallas too. Okay, you have to be a Texan. That means you have to be born in Texas, to be a native Texan. So we want the beginning to be true and the end to be false. So you need to be born in Texas, but not in Houston. Get it? That's a counterexample. You can't make both of them false. You can't make the beginning and the end false, okay? To be a true Texan, technically, you have to be born in Texas. Okay, next one. If you are a girl, then you have blonde hair. Who is a counterexample? Okay, good. So to be a counterexample, first you have to be a girl, and then you have to make sure that you don't have blonde hair. I said it right that one day. I'm sorry. So if you're raising your hand, you better be a girl. Good. Okay. Oops. We're still going. Sorry. If you play video games, then you have an Xbox. Raise your hand if you're a counterexample. Yes, Neil. So if you're raising your hand, that means you do play video games. You have to play video games, but you do not own an Xbox. So you do PlayStation or Wii or PC Gamer or iPhone. Yeah, good. iPad. Last one. Don't make me cry here. What if you have both, you're not a counterexample, okay? If you're in Geometry K, then you love math. Who's a counterexample? Raise your hand. Oh, good. Not very many of you. Oh, more people are raising their hand now. I hope that's not true. So you're all in Geometry K. You're all, or K or H, either one. You're all in honors geometry, but you're raising your hand if you don't love math, and that makes me sad. Okay. We do not have time for that. So we are done, and you can work on your homework.